Alright, y'all, so today we are going to continue talking about constant rate of change and how we can test if something actually has a constant rate of change. So just to remember, rate of change is when we are comparing y to x, or we can also say the change in y compared to the change in x. So we've been having some lessons on that as well. So if you take your y value and you put it over its x value, or we can look at the y, that's vertical when we're looking at a graph, or horizontal for x, going left to right. So we can look at a table and how the y's are changing versus how the x's are changing. And if there's a constant rate of change, those are two ways we can look at it. But here's another way we can test for that. So if we have this table, it says Miss O'Brien determines the cost to purchase different amounts of bananas from H-E-B. So for half a pound, she's paying 30 cents. So in case you forgot your sentence stem, if they didn't tell you this is y or x, the total purchase that she spends depends on the pounds of bananas. So that's going to be my purchase, which is the dollars, compared to the bananas. Okay, so if they didn't tell me what y and x was, we'd have to write that sentence stem to represent that. So we're going to answer this question in just a little bit. So when my y was 30 cents, 30 hundredths, over my x was 5 tenths. When my y was 78 cents, my x was 1 3/10 pounds. When y was 1 26 hundredths, my x was 2 1/10. So these are the prices she's paying based on how much she's buying. So $2.22 for every 3 7/10 pounds. So what we're going to do is we're going to divide. So we know how to do long division and divide with decimals, but just for a little bit of time's sake, I'm going to actually be using my calculator right now. You are supposed to know how to do this without a calculator, so if we needed to do long division, like if this were a test question, just remind yourself on how to divide with decimals. But just for time purposes, I'm going to say 30 hundredths was my y for every 5 tenths. So I divide that, and I'm getting 6 tenths. And remember, 6 tenths is the same thing as 6 tenths over 1. So when we're comparing this, this is my y, which is my dollars, how much you spent, and my x was the pounds of bananas. So that looks like it's 6 tenths for every 1 pound of bananas. That's my unit rate, 6 tenths for every 1 pound. So let's see how much it is when I pay for 78 cents. So 78 cents for 1 3/10. So if I do my y over my x, I also get 6 tenths. So we're not going to do this y over this x. It has to be over the x that it's working with that y. So now if I have 1 26 hundredths, when x is 2 1/10, we also get 6 tenths. So they are all reducing down to the same thing, and we're going to talk about what that means in just one moment. So if I spend, or she spends $2.22 for every 3 7/10 pounds, again, it's 6 tenths. So that means that these all reduce down to the same thing. So what did we notice about the ratio? Remember, the ratio is a comparison between two things, and those two things that we are comparing right now are the amount that she purchased for every pound of bananas, or however many pounds that she's buying. So we can say, I notice the ratio of y to x always reduces to 6 tenths. In this situation, always reduces 6 tenths. So this means it cost 60 cents, because that's 6 in the tens place, so we can put a 0 in the hundredths, 60 cents per pound of bananas. So that's how we can write it in words once we have that fraction. So that's what we call our unit rate, how much it is for every one of something. So let's look at another situation and see if it's similar or different. So now it says Miss O'Brien determines the cost to purchase a half gallon of ice cream for $6.99. And then different amounts of bananas from H-E-B. So she's buying the ice cream at $6.99 and the bananas. So we're going to kind of think about, is that going to be the same or different? So if she bought the half gallon of ice cream at $6.99 and half the pound, well, remember, half the pound of bananas was 30 cents, so $6.99 plus 30 cents is $7.29. So when I have my total purchase compared to the bananas again, because it's Y, my total cost, depending on what I'm buying. And she is buying that half gallon of ice cream and an additional amount of bananas. So we're going to take $7.29 for every 5/10 pounds of bananas. Then she spends $7.77 for 1 3/10. And again, if you think about it, $6.99 for the half gallon of ice cream, plus that 78 cents, because this is how much it was for 1 3/10. You would add those two together to get to this $7.77. That's where they're coming up with that number. Okay, so now we have $8.25 for 2 1/10, and here again, $6.99 plus 126 is going to get you to that $8.25. Then $9.21 for every 3 7/10. So we have our ratio of comparing Y to X. So now we need to see if they're going to reduce down to the same number. Okay, so we've got our ratios. So I'm going to say 729 divided by 5/10, and that's 1458. Just double check that. 7.29 divided by 0.5. Yeah, that's saying 14 58/100. Then $7.77 divided by 1 3/10. I get a different number. I get 5 and about 98 cents. Because when I'm talking about money, we round to the nearest hundredth. So remember, the one after the decimal is tenth, then the hundredths, and then the thousands. So if you're rounding to the nearest hundredth, you actually have to look at the number in the thousands and say 4 or less, let it rest. 5 or more, add 1 more. That's why I went to $5.98. Then I'm spending $8.25 for that half gallon of ice cream and 2 1/10 of bananas, and we get 3 93/100 when we round. Then 9.21 divided by 3.7. We're going to get, now this is where we look at, I'm glad we have this number. This is $2.48, but when you go to that 9, that's going to be $2.49. So remember, when we're rounding to the nearest hundredth, you actually have to look at the number in the thousands place. So let's think about it. What do we notice about the ratio of my Y to X? Were they all the same? Nope. We're going to say all ratios are different. And let's think about why they're different. We weren't just buying the bananas. We were doing this, adding this ice cream in the situation. So adding this ice cream into the situation, you're paying that once. So this is breaking it down to how much it was for the bananas. But as soon as we add this, it's going to make it a little bit of a different situation. So which one represents a constant rate of change? So constant rate of change, remember, means it's the same number over and over. So did we have the same number when we reduced here or here? Hopefully you said situation A. So situation A represents a constant rate of change because the ratio of Y to X is always the same. That's why it's called the constant. If it's constant, it means it's the same. Situation B does not represent a constant rate of change because the ratio of Y to X, just move that over here so you can see that a little better, is not always the same. And again, the reason why the ratio is not always the same is right here. they had an additional cost of $6.99. So later on in math, we're going to actually tell you how to write these equations, but not just yet. But if you're paying a flat rate of $6.99 and you're buying something additional, you're not going to have that constant rate of change when you're looking at that total price. So that's something to think about. So remember, constant rate of change, we're going to compare our ratio of y to x, or the change in y over the change in x. So this is how you're going to be testing for rate of change once you're given that situation.